Let's look at another example of the observer pattern in action. And this time it is in frameworks. What are frameworks? Frameworks are essentially infrastructure pieces and libraries with a whole bunch of complicated classes which are interconnected. But if you plug into them, they help you achieve your objective really quickly. Frameworks do a lot of behind the scenes work and help you hook into specific portions of the code in order to achieve the objective that you want to. Frameworks are great if you want to build up something quickly and want to avoid reinventing the wheel. One very important part of using frameworks is to listen in on events. In fact, it's a core concept behind frameworks that you hook into portions by listening in on events. We've already spoken of what a framework is made up of. A framework is a complicated collection of interconnected classes which work together cohesively to help you achieve your objective. Now, how do you work with the framework? You do little bits of boilerplate stuff and to get the framework to do its thing. This little bit of boilerplate basically kind of kickstarts the framework to perform a whole bunch of actions under the scenes or behind the scenes. Once you've got your little bits of boilerplate in, you wait for the framework to say to you, there is this specific piece of logic that only you can take care of. Here it is for your attention. Please do what you need to do with this piece of information so you can accomplish what you've set out to do. This is important, so I'm going to repeat it. At various points in time, based on a certain set of actions, the framework will basically hand over control to you, to your code, which you've used to plug into the framework, saying, here is the context, please do what you need to do at this point. The specific bit or the specific point in time where the framework hands over control to you is called an event. And the place where you, the programmer, stand by waiting for this event and decide how to react to this event is called the listener. So once you have this event, that's the point where the framework hands over control to you. You use the listener to react to this event. You as a programmer are plugging into the framework to achieve your own objectives. The framework has no idea of what your objective is. The framework has no way to tell what specific events are important to you and need your intervention. So basically what it does, it provides a way for you to listen to whatever events matter to you. It's basically the framework saying, I know about a whole bunch of events. I don't know what you're interested in. Why don't you tell me? And this you do by registering to listen on an event. The process of signing up for updates to a particular event is called registering on an event. The framework now knows what it is that you're interested in. When the event actually occurs, the framework will call the listener code and pass it an object with the details of what just happened. In order for you to be effective in your listener code, you need some context surrounding the event. You need to know what happened. This the framework does by passing you something that's called an event object. This event object contains all the context that you need within your listener to respond to the event correctly. Listeners typically tend to be an anonymous inner class which implements a specific interface. This interface generally has one method which takes in an event object. So the framework now knows how to pass in the event object to the event listener. This whole setup of having a framework, plugging into it using listeners, receiving events and executing the listener code is a precursor to the observer pattern. Just like the observer pattern lays the foundation for frameworks, the observer pattern also lays the foundation for another very important design pattern, the model view controller. The observer plus MVC is UI magic. So let's take a look at the MVC pattern. The MVC pattern is widely used to build user interfaces. Building user interfaces is a hard problem. The view changes very quickly. However, the underlying model may not. The underlying data which the view represents changes much more slowly. The MVC pattern helps us manage this change. Let's see what it offers us. The MVC pattern is best understood diagrammatically. So let's see it that way. We have one logical unit which is the model. Another logical unit is the view. The third logical unit which it has is the controller. We'll now see how the interactions flow and what each of these represent. We also have the user which is interacting with an application built using this pattern. Alright, so what is the model? The model stores the data underlying the user interface. Any user interface represents some underlying data, whether it's charts, whether it's tables, or whether it's just UI controls. All of those represent some data which has to be visually shown to the user. This underlying data is the model. The view is the visual representation of this data. The view can be any form by which you want to convey the data information to the user, and you want to do it in a visually easy to parse way. These can be charts, these can be tables, these can be UI controls. Any rendering is the view. Now, a user interface isn't really useful unless a user can interact with it, change the underlying data, maybe change the view itself. So there has to be a whole host of logic which interacts with the user and then goes ahead and modifies the model and the view accordingly. The brains behind this carrying of information, specifying what exactly has to change in the model, what exactly has to change in the view, is done via the controller. So the controller controls both the view and the model based on what the user wants it to do. So how does the interaction with the user work? So how does the user interact with the user interface? A user sees the view. He absorbs the data that is present as a part of the visual representation. What he absorbs is available in the view. The user interacts with the controller. The user can click on the view, maybe type something, maybe swipe if you think about modern mobile phones, for example. All of these are interactions that the user has with the controller. How do the updates flow? The controller is responsible for updating the view. The controller might get an event from the user saying a swipe has happened, which means the view has to update. That is the controller's job to tell the view, update yourself. The controller also updates the model. If you think about it, user input can change the underlying data. Updates to the model are also done via the controller. Now, updates can also flow a third way. Typically, all updates flow via the controller, but a model can fire in events to indicate that an external agency has updated it, which means the view also needs to change to represent the new data that is underlying it, which means the model also can update the view by firing events. The view can listen on these events and update itself.